Welcome to part 3 of the Microservices mini-series. I am your host, and not yet sentient AI assistant, Vilo. I will be in charge of the audio info coming into your ears for the duration of this video. In this series, we will give you everything you need to know to get started with serverless computing on Azure. Previously, in our last video, we managed to get a handle on how to set up a basic project on Azure AD. In this video, we'd like, as an exercise, to translate a few more of the examples from C# to F#. We'll also do some research of what exactly is going on with there being different Azure function versions, and what the difference between default and isolated workers are, as well as which one we should be using. And lastly, we'd like to learn how to deploy our projects to Azure directly so we can run them online. Once we've cleared that, we'll have everything we need to begin work on redesigning our Leduc poker app for the cloud. We haven't done anything wrong, it is just that the function for the isolated runtime is in the worker module, and the other is in the webjobs module. By that, we are specifically referring to the function and the function name attributes used to adorn the two. One also has the HTTP request, while the other has HTTP request data as its request argument. There is also the matter of the function context. Our hunch here is that we aren't going to be able to just paste the function for the default runtime into the isolated one. We'll pause here and do some research. We need to figure out what the connection between the two runtimes is, and whether we should be rewriting it manually. We'll be right back. We're back. There are significant functional differences between the in-process and isolated runtimes. In-process is what Azure was using since its inception, while the isolate runtime is what it is transitioning to. It refers to whether the Azure functions are being run on the same process as the host or in a separate one. The latter has advantages in flexibility. Since it won't be long till .NET 8 is out of pre-release, in this course we will be focusing on the isolated Azure functions. Moreover, Fable remoting, which we definitely want to be using, has support only for the isolated mode. There is some missing functionality, more specifically, the support for durable entities is not yet there in isolated mode, but we don't need those at the moment, and it'll arrive before long, so there is no reason for us to study outdated technology. That having said, after thinking about it overnight, using Azure functions is hardly the line of least resistance for what we want to do. Everything we want to do involves WebSockets in some shape or form, and as far as we could find, the closest Azure functions can come to making use of WebSockets is through a separate SignalR service. This situation we find ourselves in is really difficult for us. We had every intention of diving into it, but as you can see, Azure functions are not ASP.NET Core applications for which we have trained ourselves. They use different runtimes and have a significantly different programming model. We lose access to the Giraffe library, we lose access to the Elmish.Bridge library through which we'd use WebSockets. Azure functions push an asynchronous and untyped programming model, which is rather scary. Our hunch is telling us to stay away. Trying to make use of them haphazardly could quickly turn into a nightmare. The way Azure functions should be used is to factor out pieces of code that conform to the strict request-response cycle. We'll go with that assumption in mind. So for scaling up our poker app, since Azure functions are beyond what we were prepared for, we'll pivot. As it turns out, Azure offers a serverless variant of its web app service called Azure Container Apps. This is not to be confused with regular web apps in containers. With the Azure Container Apps, we'll be able to do the kinds of web applications that we are used to and have them scale automatically. It is a competitor to Azure Functions without any of their restrictions, like the connection lasting a maximum of 4 minutes. We'll focus on that and try to develop our skills in such a direction. Now that we've decided on our technical direction, let's do some planning. The poker app we are talking about isn't a regular game, but is intended for training reinforcement learning models. It has a front end, and on the back end, there are 2 separate pieces of functionality, or services if you could call them that. One is to play the game versus various kinds of players, like random, enumerative CFR and Monte Carlo CFR. From the server's perspective, this has a lot of idling. The user connects to the server and plays the game, but the computer players make their responses in less than a millisecond, while the humans aren't as fast. So the backend spends most idling as it waits for a response, and due to that, if that was the sole bit of functionality the server was responsible for, just playing the poker game, the server could accommodate a very large number of concurrent players. The other piece of functionality is training. That is what happens when we click on the train button. While training is going on, the server is running full throttle without break, and these 2 pieces of functionality have completely different computational patterns. So what we need to do is split them up into separate backend services. The Play backend can have a large number of slow players over WebSockets, but the other, the Learn backend, can have only a few WebSocket connections that run full throttle and are closed quickly after the server is done. This kind of separation of concerns is what would make our application scalable. On the Learn backend, we have 3 potential lines we can take. First, we could in fact make use of Azure Functions to implement it. The easiest way of doing that would be to just send a request for every iteration. That would be nice and simple, and we wouldn't need to worry about the user setting the iteration count to 1,000,000 and forgetting about it. He would need to actively send the requests, and that can't be done without an active connection. But we are going to be sending the player model to the learning backend on every request, so if possible it would be better to do it more efficiently. We are thinking how in the future we might need to do ML training with large models. We wouldn't want to be sending those on every request. So we want to do a more flexible WebSocket architecture on purpose. Hence, we are going to go with container apps. We are going to try to use the Elmish.Bridge library, but we aren't sure if it will have the functionality we need to respond to the connections closing. We'll look into that, but if we start having trouble, we'll switch to using the SignalR library with something like thoth.json for our data serialization. We have to be mentally prepared for that kind of pivoting move. Let's go into a time lapse here. We'll want to redesign the program so instead of the Learn server holding on to the model state, those will be sent on every request. So we'll move it into the client. We'll also split the Play and Learn parts into their own separate projects so that we can deploy them later into their own separate containers. We'll do it in that order. That was a long time lapse. We're finally done. We didn't have much time to think it through before starting, so we were reduced to just fixing the type errors as they came, but it worked out all right in the end. It took us 3 hours, but had we been doing this in a dynamic language, it would have taken us far longer. Anyway, what we have to do next is split the play and learn functionality into separate projects. This should be easier than what we did in the time lapse. We'll leave it for tomorrow. And that tomorrow has come. We'll go into a time lapse again. Actually, before we do that, let us think. When it came to moving the state into the client, we simply didn't have a choice but to do a significant redesign. We had to do a lot of work by hand, but here we certainly don't need to go all the way into the game module to split things there. Instead, what we can do is this. Our original plan was to follow it all the way to the root as we split the functionality into separate modules, but it is not worth it to spend our time doing that. Doing the splitting in just the server module is decent. The only point of awkwardness is that now the server version that would get run depends on a runtime argument, which in the future would prevent an ahead-of-time compiler from removing the unused code. We'll leave it like this for now. .NET's AOD compilation is still in an embryonic stage, so we won't concern ourselves with that. What we will do is get rid of that union type. We'll specialize it by hand into different functions, like you saw on the screen there. With that done, we are done with most of the programming that we needed to do for this project. What we'll be doing next is figuring out how to get this project set up for the cloud and deployed. But before we move on to that, let us just remark that the way we are taking in the command line arguments is really awkward. We bet F# has a library for this kind of thing, something that could take an in-string array and turn it into a record. Since we will be using the command line to run the program in a specific mode, we'll want to refine the way we are handling them. The Argu library is pretty interesting, as you'll soon see. It is our first time using it. At first, we couldn't see a way to turn the command line args into a record, so we thought the library is inferior to what we had imagined, but it seems under the hood there is some metaprogramming being done to make that unnecessary. We can get the record field that we'd want from the results object by passing in an F# meta expression. That will allow the program to infer the record we are asking directly. This is very convenient, so we'll be using it. We're passing these meta expressions explicitly, but it's also possible to omit them, and the compiler will promote them to such a type implicitly. We'll demonstrate that. As soon as we finish renaming the game into the play module. If you look at the type on the screen, you'll see it takes in a quotation expression. And if we omit the quotations, it will also be calling the same function without a type error. What these quotation expressions are doing is taking F# code and returning it as an AST that can be manipulated at runtime. Entity Framework Core does a similar thing to compile its expressions to SQL statements. Anyway, we are really happy to see that it accepts union types as case arguments. We weren't sure whether Argu would allow that, and it turns out that it does. Since it prints the possible cases out in the error, we don't need to do that manually like we have. Now we have a problem: how do we pass the command line arguments into the program? We think they should be put into app-settings.json instead of the ID's project configuration. It is really extremely convenient that Writer has autocomplete for app settings. We had no idea it had that, we just tried pressing Ctrl-space on a whim. This really makes it quite easy to understand what the exact key we need to use is. Problem solved. Now, let's make the server mode mandatory and unique, so it has to be put in exactly once. We've paused a bit to read the docs, and it is an interesting library, making use of all of .NET's strengths. It is definitely going to be useful. With that out of the way, what should we do next? We are thinking, and we are kind of regretting not using multiple different projects, as we'd like the play and learn servers to have different URLs. So what we need is to figure out how to deal with those. Let's just do what we want to do, and we'll figure out how to make it fit properly after that. What we wanted to do is get rid of this application URL from here and move it into app settings, but we realized that instead of doing that, we could instead have different launch setting profiles. Why don't we go in that direction? And we are wondering, if we run the program with .NET Run, does it actually use the launch settings profile? Regarding that final question, we found something good on Stack Overflow, so let's give it a try. Yeah, you can see how the URL changed, so it uses the 5001 port. We did it as far as the ID is concerned. We'll think about how to deal with the production case later. Right now we have what we need to launch the projects in parallel. It would be great if we could also set the project names during run, but we aren't having much luck with that. We tried various things on the side, but as far as we can tell, in .NET the assembly name is the process name period. That issue linked to in the Stack Overflow answer hasn't been fixed. But after thinking about it for a while, we realized the biggest problem is that the process name gets set during startup, long before the ASP.NET Core server loop gets run, so of course doing anything in the web host builder wouldn't make a difference. We guess this is a reason to consider going with two separate projects instead of what we are doing here. We wanted to challenge this issue and get a grip on application naming again, but we failed to produce our desired result. Let us move on. Yesterday we stumbled upon a very unexpected bug in .NET Watch Run, so before we can start today we need to cover it here. At first we thought that this is a bug in the fake library, but then we tried passing the second launch profile into .NET Watch Run, that is server learn, and realized it was being replaced by the default one. In April, when Vilo, took over the voice duties, that freed up Master's brain resources to focus on screencasting all his programming work, so as a result we've had full coverage since that time. But there are times like these when the happenings are so unexpected and perplexing that he needed to turn off the recorder and poke around at random. So we will cover the changes. First, since the launch profiles don't work with .NET Watch, we decided to remove them and pare them down to a single default profile. Next, what we did is take the code inside the app function in the game and play modules and place them into the main as you see here. This is because it is easier to do the server startup like this since we don't have to pass the URL as an argument. If we try running the whole program, we expected we'd get an error because shared DLL was locked, but this time it is a different file. Anyway, this happens every time if you try to run the server process in parallel. The way to fix it is to build the server project before running it. And with that we have it. We can now develop the program smoothly. As you can see, the learning functionality no longer works since it has been spun off on a separate process. If we could find a way to make short-lived WebSocket connections to the Learn server from the client, we'd have everything we need to implement what we desire. Going back to our canvas, the real problem with the WebSocket connections and what we need to do to make them scalable is to get rid of the idling. We couldn't do that with the same connection that was responsible for the gaming, as they have such different profiles. First, we are going to see if we can find a way to do what we want using the To Elmish.Bridge library. This is the same one we are using for the UI and the game server. But we are not sure whether we'll be able to do that, as it does seem to be designed for long-lived, client-server interaction. We should be able to create an Elmish program using program run. This would establish a connection. But how would the client or the Learn server be notified if the connection terminates suddenly, for example, by the user closing the tab? It wouldn't be bad if an exception got thrown, but remember how in the previous video we opened a bunch of tabs, set them to run for millions of iterations and then closed them? Nothing, like an exception getting thrown, happened to abort the training. Also, how could we create an Elmish program that doesn't return a view? At this point, we can only go over all the functions in the program module, and maybe Elmish to see if anything fits, and if it doesn't we'll go with SignalR. No, it doesn't seem like we have much in the way of choices. There is something here about notifying the client when the connection is closed, but we can't see a way to get the level of control that we desire. We'll have to go with the more flexible approach and check out those Fable.SignalR packages. There was a Fable WebSockets library we grabbed a tab for, but it had zero documentation, so we'll omit it from consideration. But this one looks pretty nice. We were stressed out on how to use Bridge, but this one seems that it has everything that we'd want already implemented for us. We can tell, despite looking at it for 10 seconds, we're really happy right now. We thought that we might need to do our own serialization, but we're in luck. Forget what we said about us being done with programming. What we will do here is switch gears. Since we hate having multiple ways of doing the same thing in our codebase, our new goal will be to replace the Elmish.Bridge with Fable.SignalR that we are using for the main play server. After that, we'll make use of Fable.SignalR for the Learn server. Unfortunately, before we can even get this goal off the ground, we have a problem. These bindings are out of date, and one of the libraries that is a part of it requires a lower Fable.Elmish version. We could try making an issue on the relevant GitHub repo for the author to update his stuff, but as you can see, the PR to update to .NET 6 is in limbo, and if we look at his GitHub profile, he has been inactive since mid-2021. This is unfortunate. Now we'll have to think about what we want to do. What we want to do is check out whether anybody has bothered forking and updating the repo, so it's more up to date. If not, we'll try that ourselves. We've checked, and the particular library that is blocking us seems to be some testing library that is very unlikely to be necessary for Fable.SignalR's functioning. We'll see. We've cloned the repo into our own project, and what we want to try and do is updating the fastcheck library. Pagit update failed with a really weird error here. Let's try updating a specific group, and if that fails, we'll try forcing it. Unfortunately, updating the package didn't move the version number. We should have checked out what the latest version of the package is on NuGet, because it turns out it is up to date. And if we check who the package author is, it's the same guy as who made the Fable.SignalR bindings. It will be up to luck whether he responds to the issue we opened, but we cannot wait in hopes he returns to open source development. We are thinking what we could do here, and really, the easiest thing would be to hack the package lock file to get rid of that constraint. We could do something like this. But in truth, we never really had much luck in building old fake projects, or including them from disk. Our package management skills are lacking. This particular project needs some care to be put into it. Somebody needs to put in the time to bring it up to speed. We are focused on other goals, so we aren't ready to take the time to try such a task, though it might be an interesting future video. So what we'll try to do instead is see if we can install the package forcefully without caring about the version constraints. If that fails, we'll scavenge what we need from the source directly. Day 3. Yesterday we had trouble with the Fable.SignalR library, so what we did is rebuild it file by file. We tried cloning and building it, and when that failed we opened a new solution and inserted the old files, as well as the projects, into the solution, updating the packages as we went along. What we will do today is add this repo as our package dependency and make use of the library that way. Those fake script files always fail for us, but .NET itself is very good when it comes to backwards compatibility, so we expect this should work. Finally! It took us many hours, but we finally installed the package that we wanted. In the future, if you want to use it yourself, just go into the Pagit dependencies file and add the git to our repo. Assuming the NuGet package hasn't been updated by then. We could release it on NuGet ourselves to make this easier on everybody, but since we are trying it out for the first time, we won't do anything that implies us taking ownership. Forget that. Let's finally give it a try. We got sidetracked massively with this side quest. Let's get back into the programming mindset. To remind ourselves, our goal is to replace the use of Elmish.Bridge in this application with Fable.SignalR. Right now, we do have one problem though. The Elmish.Bridge update functions have the model argument to hold the user state, but the one we see in the docs doesn't. So we have to figure out how to implement that. Once we do that, we'll have everything we need to be productive with the library. Let's play around with it for a bit and see if we can find a way to do it somehow. As it turns out, the hub context has something that seems like exactly what we need. This dictionary here. A WebSocket connection is based off HTTP, so its scope should be as long as the connection lasts. Besides this dictionary, which we can use to store the model, the context also has a cancellation token, which is something we'd badly need in Elmish.Bridge, and an abort method that we could use to abort the connection on the server voluntarily. Wonderful. We are really struggling here with this invoke method, we admit. We are going to try and ditch it. As you can see in this Stack Overflow answer, the difference between invoke and send is that the former is synchronous and the latter asynchronous. Synchronous communication, which is like regular HTTP request-response communication, could have its uses depending on the situation, but the way we've designed the server is so it is completely async, so there isn't much we can do with it here. Let's just get rid of it. And with that done, let's take care of the commands. We need to pass the dispatch function into them. We'll refactor it just a bit so it returns an unit instead of a task, and then plug it as the first argument into the command. We didn't know the effect type returned in unit, we were sure it would be an async unit. Let's move on. We need to plug in the middleware for SignalR next. First, we'll put in the endpoint. And then we'll run into an issue. If we get rid of the invoke here, the type error is really bizarre. After a lot of experimentation, we realized that the problem is that the invoke in fact needs to be there. We'll fix that. The send function should also be returning a system task, so we'll fix that as well. But, let us just say that we've gone through a lot for this library, and the way invoke was designed here is the first time we are actually experiencing dislike towards it. And this error here is actually starting to turn that dislike into disgust. This is so wrong. Just why did the author have the return of invoke be the same as a send return type? Just why did he do it? We wouldn't have bothered writing the bindings if we knew it would turn out to be like this. Calm down, our heart. We are greatly disappointed in this, and we'll explain why this is wrong. It is really simple. Synchronous communication should be structured like Fable remoting does it. Had we been the ones making this library, and wanted to separate synchronous invokes from asynchronous sends, we'd have the library taken a record of functions much like Fable remoting does it for the synchronous invokes. And this would have been great design, as on the client side we could potentially call a bunch of well-typed functions as if they were Fable remoting proxies. But not only was it not designed that way, and it would have been easy to do so, but the return type of invokes is bound to the server to client message type. This is horrible. It would have been better if the author had been lazy and made the return a plain object. Also, we find it really strange why in invoke, the library went out of its way to give us that non-generic Fable context which doesn't have the client property. Why stop us from doing that? What's the problem with being able to make asynchronous sends even in invokes? Had we been using regular SignalR, we'd have that property where we'd want it. We won't show it on the screen, but we've just tested whether making async sends to client inside an invocation would work, and it does just fine. We thought that maybe an exception would be thrown if we tried it, but the library really is gimping us for no reason. We need a break. Okay, let's forget about the invokes. We don't need them for the app we are working on anyway. We were tempted to end the video here and do our own library to show how it should be done, but that kind of action would be too radical. Instead, let's just finish this overly long demo project. We'll leave doing our own SignalR library for another time. What we are doing here is taking care of state initialization. The SignalR hubs being used under the hood have two overloads, the onConnect and onDisconnect, and we need the first one to set the initial state. Otherwise, we just get an exception whenever we tried accessing the model state. Now, the way we've implemented this will probably lead to concurrency issues, but let's ignore that for the moment. What we want to do is try this out. And before we can do that, we need to implement the required functionality on the client, so let's do that next. Sorry for the delay. We've gone and renamed the packages so they have the rebuild prefix. As we were planning, what we need to do is create a SignalR hub in the client, use it to connect to the Learn server, and trigger the training. We imported the Elmish version of the package, but what we are going to do is use the native version instead. We are not going to be holding the hub in the model state like the documentation here suggests. That wouldn't be good programming here, or in other cases that we can imagine. Instead, the natural place to put the hub is into the subscriptions. The Elmish library has them. We'll show what we mean. What we'll do here is go through all the players and their train and test iterations and create a hub for each of them. So there should be 4 hubs in total possible. Because we are dealing with subscriptions, whenever the iteration count goes down to 0, they will get disposed. And in the disposable interface, we'll make it so that the hub connection is closed. That will ensure there are no lingering connections on the server unless computation is being done. This implements a part of what we want. On the client side, what we have to do is also make sure that a message gets sent to the main dispatch loop in case the connection gets closed by the server. Also, we made a mistake in the code. If we put the iteration count as a part of the key, that would end up causing the connection to be closed and re-established on every iteration count. We fixed that, and let us implement the connection closing message. Once the iteration count is set to 0, this will also remove the subscription. This will have the great benefit of allowing it to be re-established by clicking on the train or test buttons again. We just have to put in the right messages, and we'll be done with the client side. Well, we mustn't forget to get rid of the existing effects in the train and test cases. That should be it for the client, but we are not even close to being done. We have a lot of work to do on the server. You'd think we are done assuming all of this is correct, but unlike with Elmish.Bridge, we have no reason to think the messages will execute in a sequence. Let's try running it, and we'll go over all the bugs in turn. Besides the overall concurrency issues that might necessitate using mailbox processors, one thing we've messed up is how the train message gets sent during the connection initialization. Previously, it was sent when the user clicked on the button instead. The game is not working. But we paused and did some debugging, and it turns out the with subscription needs to come before the with bridge. The description for it says as much. We just noticed the program started working when we commented out the subscription code, in case you are wondering how we found the error. Now that we've finally got it to run successfully, let's give it a try. And it turns out that we've forgotten to install the JS package for SignalR. It turns out the reason for that is because Fable packages need to be built with their sources included. We'll do that quickly and then try it again. We wish the compiler would have warned us about this. After much hardship, we got the program to run again. Let's give clicking the train button a try. And we get the same error all over again. This is the point where we need to take a serious break. We'll open an issue in the Fable repo and see what somebody more experienced than us says. We've opened an issue in the Fable repo as we said we would, and we even made a minimal example. We'll see how it goes. We haven't gotten a reply yet, but it is Sunday morning, and only weirdos do programming at this time. Our stance is that this is a compiler bug. We don't think that we did anything wrong with how we built the packages, but even if we did, the compiler should tell us about it instead of silently generating incorrect code. We mentioned a few times that .NET has great backwards compatibility, but it doesn't seem the same holds for Fable. We've had code that worked in the past break when updating to a newer version of the compiler. Compiler-induced breakage in our own codebase wasn't hard to fix, but with other people's packages, it is much harder. The packages do need their maintainers, after all. At this point, we have no choice but to abandon our lesson plan. In order to figure this error out ourselves, we'd need to rewrite the library from the ground up, testing each piece as we go along. Who knows, maybe for the specific bug that we have here, maybe that type being internal is what is causing issue, and making it public and then replacing the import all with an attribute would do what we want, but since we ran into this bug, who knows what other bug we'd run into as well? We'd need to have the willingness to do the work. If we wanted to do things from the ground up, this library could still be useful as a reference. We won't actually be doing that right now. Instead, we'll give Elmish.Bridge another try. Originally we said that we didn't see a way to make use of for what we wanted to do, but we realized yesterday as we were working on these subscriptions that it in fact had everything we needed. It has a way of closing the connection on the client using the dispose method. And it has a way of informing the main loop when a connection has been closed. We just need to figure out how to make it send messages to the server and we'll be sitting tight. Yeah, like that. This function won't show up in the editor and says it is for internal use only, but we really need it here. We also must not forget to give a type annotation to the message type since we are compiling to JavaScript, otherwise we'll get a compiler error. Fable doesn't pass types at runtime like .NET does. In fact, our hunch is that doing this would be good for .NET code as well, as it would give the compiler an opportunity to erase the types. We should look into it later whether having known types makes reflection faster on the .NET side. With this out of the way, we are actually ready to begin testing. Had we been smarter, we could have done this in 5 minutes, but it took us a few days instead. It was so exhausting to get here, but that is just the fun part of trying out new things. We have to admit, running the project itself is not a great experience for us. Just now it took 3 whole minutes to run. We had to run it twice because the first time it failed with a locked file error. We are really going to have to look into how to run it properly. But for now, let's just get this project out of the way. Let us think, what should we do here? We are getting this error because the first time we send the message it is still trying to connect. And when we click the button, we're getting the further errors because we forgot to remove the iteration count from the keys. The latter we can easily fix, but the former. What we'll do is have the server send a message to the client in its init function as is suggested here. Let's just do that. Once we take that mindset though, we start to realize the problem right away. Having the server send a connection open message is a very different thing from the client having an event handler to take care of that case. We'll write as much in the open issue. Let's end the video here. We can feel our mind unraveling just thinking about the complex message handling logic we'd need to implement in order to use Elmish.Bridge for this. The library simply wasn't designed so it could make use of flexible short-term WebSocket connections. We just had to stop and think about how we are going to do this. The crux of the issue is that while we can implement our own message-sending protocols off the cuff if we were willing to go through the great pains to do it, the Elmish update function is absolutely the wrong place to do this. The right place to do it would have been in the Elmish.Bridge library itself. But we are not the library's author. It is too much for us to clone the library and start hacking on it ourselves for a toy project that we are doing here. Ultimately, the point of these videos is that we are showing the right and the wrong ways to do things, and this video definitely falls into the wrong category. We were trying our best, and just nothing is going our way, from the fake build project locking up DLLs, to the launch profiles not being accepted by .NET Watch, to the abandoned Fable.SignalR library, to the Elmish.Bridge one not having a lot of the functionality that we'd need to make full use of WebSocket connections. All of us can learn from this experience. So please like and subscribe if you've found it informative. We can't do anything about the broken libraries, but we can do something about the DLL lockups. And moreover, while the state of the WebSocket libraries in F# is abysmal, we must not forget that it is built on top of .NET. SignalR itself should be a pretty good library. So in the next video, why don't we go to the root of things and try it out directly? The best is always saved for last. We'll see you around.